In this video, we are going to look at how to use Dijkstra's algorithm to find the shortest path. Dijkstra's algorithm is a systematic way to find the shortest path between two vertices. So I've broken this down into 5 steps here. Step 1, mark the ending vertex with a distance of 0. Designate this vertex as current. Find all vertices leading to the current vertex. Calculate their distance to the end. Do not record this distance if it is longer than a previously recorded distance. Mark the current vertex as visited and do not return to this vertex. Mark the vertex with the smallest distance as current and repeat step 2. Stop once you have found the shortest distance from starting to ending vertex. So let's look at how to use this. Here we have a graph and we want to find the length of the shortest path from vertex A to vertex L. So we'll start at vertex L, which will be our end, and that will be our current one. We'll mark it with 0 because it's 0 distance from itself. There are 2 vertices that are connected and lead to this vertex. I is 28 away from L and K is 22 away from L. 22 is the smallest distance. So we're going to mark that one as current and go there, marking L as visited. And as it mentioned, we're not going to go back to L once it's marked off. So now we're at vertex K. Vertex K also has 2 vertices leading to it. Vertex H and vertex J. Vertex H is 30 away from the end because 22 plus 8 is 30. Vertex J is 42 away from the end because 22 plus 20 is 42. Looking at the vertices that we have right now, we actually have 3 that are marked off with numbers that have not been used yet. Of those 3, 28 is the smallest. So we're going to go to I and mark off K as visited. Because we're going to I, we're going to cross out the path that we did take to get to K and forge a new path going to I from vertex L. Now that we're at I, we have 2 vertices that lead to I. F is 33 from the end because 28 plus 5 is 33. And we've already got H marked as 30. 30 is the smallest. So we're going to go to H, marking off I as visited. Now that we're at H, H has 2 vertices that leads to it. E is 43 from the end because 30 and 13 is 43. G is 59 from the end because 30 and 29 is 59. And we have 4 different vertices here that are labeled from the end. The smallest one is 33. So we're going to go to F, marking off H as visited. And since we're going to go back to F, we're going to cross out that path we took to H because we're actually not going to use H anymore since it's going to lead us on a longer path. There are 2 vertices that lead off from F. We already have the distance E is from the end. C is 42 from the end. 42 is less than 43, so we'll go with C. We'll mark C as current and cross off F as visited. Now that we're at C, since we've already visited F and can't go back, the only option we have is to go down to B, making B 45 from the end. And from there, our option is A and E. And our ultimate goal is to get to A. And so we'll go ahead and just go straight to A, adding 25 to our 45, giving us the shortest path of 70. Now this problem doesn't ask us to name our path, but it's good to practice naming it. From where we started, our path would be L, I, F, C, B, A. However, it does ask you for the length from A to L. Flip that around and name it with the A first. So you could name it A, B, C, F, I, L.